Good morning, all of you. Now it's the second class. We will consider that is the different plane having unbalanced mass. In previous class, there is a one plane having different masses are there, but here is the different plane. Different plane means this is the shaft. Here is the this is the mass m1. This is the mass m1 that create the unbalance. And this is the another plane of this shaft. There is the mass m2. There is a mass m2 that creates the unbalance. And this is the another plane having mass m3 that creates the unbalance. And this is the shaft having a fail. If we consider these three masses that creates the unbalance. So for balancing these unbalanced mass, we add, you can say that we add a mass here and we add a mass here in any direction, mass here mb1 and this is the mb2. These masses we have to find out, these two masses, that system will balance, that will be balanced the whole system. Then you can say that more than three, you can have different plane having there. In problem, in question, we have masses m1 m2 m3 m4, that is we consider this is the mn, कितने भी हो सकते हैं. So for balancing these two masses we have to add and the system is balanced. So how we will solve this problem? This m1 mass creative centrifugal force f1. This m2 mass creates a centrifugal force f2, and this m3 mass creates a centrifugal force f3. So there is a couple formation is also there due to their different plane. So we consider both. So for reference, we consider this is the reference plane. Here we consider the distance of first plane. If we consider this is the distance for mass m1, consider this is the length l1. This is the reference. Here from this is we consider the distance. For m2, this distance is equal to l2. For m3, this distance is equal to l3. This distance is equal to l3. Okay. Now, and this is equal to this is the distance. You can see that LB2. This is the LB2, and for this mass LB1 equal to 0. LB1 equal to 0 for this mass. This is the reference. So first we draw a torque polygon, or due to this couple torque polygon. Two polygon we can made in this problem. This is the torque polygon, then we force polygon. In previous problem we only draw the force polygon. Due to this because of there is no couplage formation and a single plane is there, but here a different plane is there. So this is a dynamic problem. Here we first draw the torque polygon. So torque polygon, what is torque? How we will calculate the torque for this mass m1? If this force F is multiplied with distance L1, then we find out this the torque value, F into R. This is the torque. So M1 into R1, this radius M1 R1 into L1. For force F1, that is equal to M1 into R1, but this torque we will, that is equal to M1 R1 into L1, M1 R1 into L1. Similarly, the torque T2 we will calculate. This is the M2 R2 and the distance L2 from this reference. Similarly, T3 we will calculate M3 R3 and T3. M3 R3 and L3. Sorry, this is the L3. But for this mass, we did not have the how much mass we will add. Then we hold on this here and draw this T1, T2, T3 in a torque polygon. So for going to the torque polygon, first we draw the space diagram. What is space diagram? Space diagram, we will consider a shaft at a point. And this mass M1 having the angle with the horizontal reference in a question already given. In the previous question, similarly, मैं इसको 1 मिनट के लिए रब कर रहा हूँ और आप इसको पिक्चर को, इमेज को माइंड में रखना और स्पेस डायग्राम बनाना है. दिस स्पेस डायग्राम, देयर इज फ्रॉम रेफरेंस या हॉरिजॉन्टल लाइन, देयर इज एंगल गिवन फॉर दिस मास m1. दैट m1 जो डायग्राम में आपने दिखाई दे रहा था m1, तो उसका कुछ ना कुछ आपको एंगल दिया रहेगा, दैट इज द थीटा 1. सिमिलरली फॉर मास m2, there is the theta 2, and similarly for mass m3, there is an angle, that is the theta 3. Theta 1, theta 2, theta 3, this angle is given. Now we will draw the torque polygon. This is a space diagram, and now torque polygon. For torque polygon, there is a torque T1 equal to M1 R1 and L1 is M1 R1 L1. So we draw this torque. Similarly, we consider the converted into in the scale and draw this. This is the M1 R1 and L1. Another, this torque T2, that is equal to M2 R2 and L2. So here we draw M2 R2 or L2. Similarly, torque 3, we draw M3 R3 and L3. In previous question, we already discussed here that this value comes, this M1 R1 L1. If this value is come kg R1 into L1, kg meter square, mass acceleration meter, and L1 and kg meter square. This is the torque. So this torque we will assume in the scale. Then we draw. This is the torque polygon. So this point we will add from this, you can say starting point, we meet with the end point. So this is the direction of this, you can say, mass. Which mass? This is the unbalanced mass. Which direction? And this is the torque T, you can say that torque TB2. This is equal to MB into में RB और into में LB2, RB2, MB2 और LB2. This is the torque TB2. Okay. We measure here and find out this value of the torque, and this distance we have already, you can say, for calculating this distance, how much distance we add already given in the question. इतने डिस्टेंस पे हमने कितना मास हम ऐड करें और ये रेडियस गिवन है, तो उस पे हम यहाँ से वैल्यू निकाल सकते हैं मास की, या फिर हमारे पास ये डायरेक्शन आ गई है कि इस डायरेक्शन में हमारा क्या लगेगा, मास लगेगा. तो ये रिजल्टेंट हम यहाँ पे ड्रा कर देंगे. this resultant we put here and find out the angle. Find out the angle theta b2. This is the angle theta b2 resultant, and the opposite of this we make an, you can see that, mass. This is the mass mb2. This is the mass mb2. Okay, but we solve this problem, we have to add two masses from a one at the left of this and one is the right of this. But only we, with the help of this torque polygon, we find out the one mass. But second mass we consider it's a reference plane. Due to this, the mass is, you can say that, 0. Value of mass here, you can say that length L1 is 0. Due to this, the torque is 0. But in the force polygon we find out this second mass. So force polygon, force polygon, similarly this diagram, this is the force F1. We draw the force F1. What is the value of F1? That F1 equal to m1 into r1. We can find out value and then convert into the scale formation, and this is the F1. F1, this is equal to m1 into r1. Another force is m2. M2 here we draw similarly in previous question. This F2 equal to m2 r2, and then F3 we draw this is the F3. F3 equal to m3 r3. Okay, and then another, you can say that this is the force we draw here, and this is the FB2, that is equal to MB2 into me, MB2 into me, you can say that RB2. So this is the resultant. This is the resultant of these force F1, F2, F3 and FB2. This resultant force give us the direction. Resultant force give us the direction of mass MB1. MB1, this is the resultant. You can say that FB1. FB1 equal to MB1 multiplied by RB1. This is the direction, and we measure here, and this we calculate the force. This is the force, and here the radius is given, then we find out the value of MB1, mass MB1, and here we find out the mass MB2. So with the help of these torque polygon and force polygon, first to torque polygon we find out the one mass, and with the help of force polygon we find out the second mass, and then both value MB1 and MB2 we will calculate with the help of this torque polygon and force polygon. So this is the balancing of several masses in different plane, and this is the dynamic problem, because we consider this is the also a couple also that creates a torque, and the torque polygon and force polygon, both with the help of this we find out the unbalanced masses. Thank you.